Welcome to my YouTube channel. I'm Aria Humza, and I'm going to be presenting an idea I came up with using AI, a house and land price predictor. This predictor is meant to basically predict the prices of houses and land. Um, the problem that I'm attempting to solve is that of unfair pricing of land and houses in society. This is a very rampant problem that goes unnoticed because it happens more than we think it does. Um, by solving this problem, um, we shall create a fair and unbiased environment when it comes to real estate management. It, it prevents buyers and sellers from being scammed and also facilitates the general process of urban planning. By predicting these prices, I feel that this AI system can also roughly identify the current state of the economy. The way I'll apply AI when solving this problem is by getting data from data sets such as different houses with set prices by the government, um, land that has been put up for sale by KCCA, and analyzing this data to find the selling points for housing and land. And using this data, we shall be able to roughly predict the prices for land and housing. The data I'm going to be using to solve this problem shall be image, text, and numeric data. Um, image data will be used in a way that the AI will learn the different aspects and attributes that contribute towards the pricing of land and houses. Such attributes would include amenities, appearance, and locations, and many others that would decide on the final price of housing and text to different extents. I'm also going to be using text data. Text data will be used to determine the prices, to predict the prices of land and housing based off of information such as location, for example, the location of different pieces of land greatly contributes to its overall price, development, crime rate, etc. And numeric data will also be significant when trying to solve this problem because shall need basic data like size in acres and square meters for land and housing, number of stories of houses. Such information shall be very crucial when trying to solve this problem. Differences between supervised and unsupervised learning. Now, supervised learning involves observations being put into criterion categories based off of matches with existing data, and unsupervised learning is basically the opposite. In simple terms, supervised learning involves use of labeled data, whereas can predict the outcomes already. Like the outcomes are already known for specific data sets that are being used to train the AI model. Well, unsupervised learning involves the AI model doing this on its own. So we can get some some differences here. Supervised learning involves the use of input data, while unsupervised learning involves the use of unlabeled data. Oh, sorry. Supervised learning involves the use of labeled data, while unsupervised learning involves the use of unlabeled data. Supervised learning's main goal is to predict outcomes for new data using previously predicted outcomes for the already existing data sets. While the main goal of unsupervised learning is to gain insights from large volume of new data of large volumes of new data. Insights could be like findings made by the AI using data that has been given to it to train by itself. Supervised learning is a simple method for machine learning as compared to unsupervised learning, which involves a lot of computational complexity. And supervised learning also involves, it has a high degree of accuracy because you know what to expect, while unsupervised learning is not very accurate as a lot can happen when you're giving AI a large volume of unlabeled data for it to learn to train itself on. So shall be using a bunch of supervised learning techniques to solve this problem. One of them is going to be regression. This technique involves a prediction of a single output value using training data. In this case, regression could be used to predict house and land prices using data such as size, zip code, and location based off of previous training data that was used to train this AI model. Another algorithm that we shall be using is the support vector machine. This algorithm finds complex relationships between the data being used without the need for me, the person developing this system, to do individual transformations. It is very good for working on smaller data sets with many features. Now, for example, housing and land involves a lot of features, some features which cannot be seen by human beings themselves that are complex, and these affect the total price of housing. Same thing with land. So support vector machine can help out with such complexities. We shall also be using unsupervised learning techniques to solve this problem. One of them is anomaly detection. This algorithm involves identifying data points in data that do not fit the normal pattern and trend as it usually does. For example, um, if we have used different pictures of housing, good housing, stable, structured housing to train this AI, and we bring a picture that involves an abnormality, for like a leaking roof, for example. This anomaly detection algorithm should be able to find this abnormality and realizing that this does not fit the trend as other pieces of housing, and it will be able to find out different anomalies which would otherwise lower the value of housing and land. Another technique in unsupervised learning that we could be using to solve this problem is association. Association is a technique that is used to find relationships between the variables in large data sets and determine the sets of items that occur together in it. Through associations, outcomes can be predicted off of previous data. Some of the technical challenges that are likely to be faced. A problem of bias. It is possible that there will be some bias towards certain results, and this could stem from the use of low quality data. Poor, poor infrastructure. Um, Poor infrastructure could affect this problem, this AI project significantly because of the low computing power to run IT operations, unstable internet connection to operate some required frameworks, and many other things related to poor infrastructure that could hinder this whole process. Also, the determination of the right dataset, since it is impossible to configure AI algorithms to control the flow of low quality and inaccurate data. This comes off as a challenge since a wrong dataset that is being used to train this AI can cause significant issues. Some of the solutions to these challenges, um, use of a large dataset can help eliminate this problem of bias that comes along with AI system. Um, Also, the development of easily explained algorithms that can easily be read can also eliminate this problem. Poor infrastructure can be solved by upgrading the equipment, the current equipment I have, to systems that have higher processing power, and also cloud computing could be a good solution to this because I'll have to rely on the processing power of other computing services instead of my own device, which would be cheaper in the long term also. To solve the problem of determination of the right data set, a person can get in touch with various AI experts and work with the owners of different data sources such as um, houses and their prices to overcome these challenges, working with people who actually work in real estate to help out and give the right data set to train the AI model. Differences between accuracy, precision, recall, and F1 score. These four things that I've just mentioned are different evaluation metrics for finding out how accurate, I could say, an AI model is. Accuracy is the best metric for model evaluation. It can be got as a ratio of the number of correct predictions. Those are the true positives and true negatives to the size of the total data set. True positives, true negatives, false positives, and false negatives. Precision is a measure of how many positive predictions made are actually correct. In this case, I mean true positives. It can be got as a ratio of true positives to the total true and false positives. Recall is a measure of how many positive cases the classifier has correctly predicted over all the positive cases in the data. It can be found as a ratio of the true positives to the sum of true positives and false negatives. While F1 score is a measure that combines both precision and recall, its formula is as follows on the presentation slide. For this project, I believe that an appropriate evaluation metric we could use is precision, because the classes that need to be classified in this project are very imbalanced, and precision can help out with that. It's meant to work with unbalanced data and find a rough metric using this unbalanced data as compared to accuracy and recall, which is the opposite. F1 score can also be an appropriate evaluation metric, because in this case, choosing both precision and recall score can greatly impact the model in terms of giving false positives and false negatives, respectively. F1 score solves all of this. Some of the references I used to create these slides are provided here. And I'll link them down in the description. Thank you for watching, and hope I can make another video next time.